Okay, this is the 2016 edition of Maths paper. We are looking at question 4, which is a differentiation from first principles question. Now, some people like to use y in this and then use y plus delta y in their proof. I don't like doing it that way, so I'm going to rename this straight away f of x. So my function of x is x squared plus 3x. Now, because I know how to differentiate, I should already know what the answer to this is going to be. It's going to be 2x plus 3. So you always keep that in mind when you're doing this, because you want to make sure that that is the answer that you get. So my formula for first principles is that the dy by dx is f of x plus h. Right, I should say the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay, so we're just going to make sure we have these parts of the expression. F of x I've got, f of x plus h I need. So f of x plus h means whenever I see x, I'm going to put x plus h. So when I had f of x, it was x squared plus 3x. When I have x plus h, it's going to be x plus h squared plus 3 lots of x plus h. Okay, in the same way, so x plus h, x plus h, x plus h. Okay, let's just get rid of those highlighting because they're not really of any use to us. Okay, so it's worth expanding these brackets. So the first bracket there, the x plus h squared, is one that I would advise you to go away and learn. You square the first is x squared, you double the product is 2hx, and then you square the last, which is h squared. Now, with the first principles work that you're doing at additional maths level, you are going to need to use that every single time. So if you learn it, it's much easier. Okay, then we've got plus 3x plus 3h. This is my f of x plus h. Okay, now I'm going to try and sort out this top line. So I have f of x plus h minus f of x. Well, that will be this f of x plus h. And I want to take away these terms. And I have to be careful. I need to make sure that I take those away. I'm taking everything away, so I need to put them in brackets. Okay. At this point, actually, I could put the over h in as well, because that doesn't overly do anything. So if I put the over h in, okay, from the equation, and I'm just going to neaten up the top. So what we'll get, and this will always happen, is you should be able to cancel out everything in that bracket. So we have x squared minus x squared. That's going to cancel out. We have 3x minus 3x. So they're going to cancel out, leaving me with 2hx plus h squared plus 3h all over h. Now the numerator has h as a factor. So we get 2x plus h plus 3 over h. And then a factor of h on the top will cancel with a factor of h on the bottom, leaving me with 2x plus h plus 3. And there's nothing I can do to simplify that. So now I come to my formula to say, well, dy by dx is the limit, as this h goes to 0, of the 2x plus h plus 3. So that is going to be, well, if h goes to 0, the 2x is going to stay exactly the same because that doesn't involve h. This h term, this plus h, is going to tend to plus 0, so that's going to disappear. And then the plus 3 doesn't have anything to do with h, so it's left with plus 3, which is what we said our answer was going to be when we started.